Hi. So in this video, we are going to discuss the difference between correlation and causality. And also we are going to discuss why those two ideas cause that much of confusion in statistical analysis. So first of all, let's start with definitions. So correlation is related to situation when two phenomena tend to co-occur, and causation or causality exists when one of the events can be characterized as a cause and the other event or events can be characterized as the outcome. So you can already see that there is some difference. But before we proceed, let's discuss types of causality. So we are mostly dealing with two concepts of causality, although there are much more of them. But mostly we distinguish between deterministic causality and probabilistic causality. So deterministic causality means that event A occurs if and only if event B occurs. If B does not occur, A will not occur either. Probabilistic causality means that occurrence of event B increases the probability of event A occurrence. So for instance, I can give you an example. So we know that smoking causes cancer. And now you can decide whether it's about deterministic causality or probabilistic causality. If it is deterministic, it means that if you do not smoke, you will never have cancer or lung cancer at least, which is not true because people still suffer from this disease even though they might be non-smokers. So in this case, we deal with probabilistic causality, which means that smoking increases the probability of lung cancer. And in statistics, actually, and econometrics, we mostly deal with the concept of probabilistic causality. Okay, so now let's discuss the fallacy of causality. We know that smoking causes cancer, and the question is, how can we know that? And the answer is, we know that because there was some research conducted. So we can understand the mechanism of developing cancer because of smoking. We know that some elements, whatever, I've never been good in chemistry, in tobacco smoke are generating cancer cells. So that's why, we can actually conclude that smoking causes cancer because we understand the mechanism of developing cancer because of smoking. There were some medical studies conducted. And now consider another example. Teenagers featuring the higher level of anger listen to punk music more often compared to teenagers featuring low or average level of anger. And based on this, we conclude that punk music makes teenagers angry. Actually, this is an example from one of the actual studies. But here, the causal relation is extremely questionable. So we can indeed conclude on correlation because, it indeed happens more often. So two phenomena tend to co-occur, higher level of anger and more frequent listening to punk music. But we do not understand the mechanism. There is no information about this. That's why it would be an extremely strong conclusion if we conclude on causal link between those two phenomena. Perhaps they are both affected by some different phenomena. I don't know, like dysfunctional families, yeah? So they make teenagers more angry and they affect their listening habits. So this is the conclusion, It's relatively easy to make a conclusion about correlation, but it's extremely hard to make any conclusion about causal relationship between two variables. Typically, you can make this conclusion only if you can explain the mechanism and you can understand the mechanism. I mean, this causal mechanism between two phenomena, like in case of smoking. However, in social sciences, it's not that obvious. That's why, detecting causal links is more problematic. So typically, we assume them based on some predefined theory. And just to make a conclusion, causality always means correlation. So if smoking causes cancer, then smokers will suffer from cancer more frequently compared to non-smokers. However, correlation does not immediately mean causality. So there is no two-directional link between those two phenomena. Okay, I hope it's more clear now. That's it for this topic, and thank you for watching.